Okay, so question number 5 here. So an indefinite integral is there's no interval to integrate from. So I call it generic integration. All right. So with A, um, I looked at that and thought, okay, you got to split up the numerator. All right. So I wrote the original problem. Split up the numerator is put the denominator. So I took the first part, x squared, put it over x, and put the second part also over x. All right, so that's my first move. Now, you could make it two integration things. I don't. I generally just put parentheses around it. All right, so when you simplify that, x squared divided by x is x. Now, this would be, I did the work off to the side. A third root is a 1/3 power. And then the x on the bottom would be a power of 1 or 3/3. And we're dividing, so you subtract. So 1/3 minus 3/3 is negative 2/3. All right, so that's what I simplified it to, or reduced it, or wrote it as, whatever words you want to use. And then I did the calculus on it. Add 1 to the exponent, goes to 2, divide by 2. Brought the plus sign down, brought the coefficient down, add 1 to the exponent. So if you add 1 to negative 2/3, it's positive 1/3. Divide by the new exponent. The plus c is just that generic constant. All right, so dividing by 1/3 is the same as multiplying by 3. So this, I just left it alone. 4 times 3 is 12. I rewrote the 1/3 as a third root. Sometimes people do that move. Sometimes they leave it x to the third. To me, it's arbitrary. If it's multiple choice, obviously, you choose whichever one. All right, now, the next one was considerably harder. I looked at it, and I did a little kung fu, because I didn't see it right away. And then I realized, dude, it's just U substitution. All right, so I could show you some of my kung fu. I did some Pythagorean identities. And I'm like, dude, it's just U substitution. So you're U. And U, it should have been obvious, but for whatever reason, I knew secant squared was the derivative of tan. And then I'm like, all right. So I took the 1 minus tan x that's squared, all right, and made the inside my u, that 1 minus tan. The du is the derivative of that. So the derivative of 1 is nothing. The derivative of negative tan x is negative secant squared x dx. Now, I needed the secant squared x dx. I didn't need that negative, so whatever, I multiplied both sides by -1, divided by -1, whatever, however you want to think of it. Then I put it in U substitution. So this little thingy goes out front, the minus sign, all right, as thingy, and it was U squared because it was 1 minus tan x, the quantity squared. So U squared du made the calculus super easy. So brought the negative down, boom, add 1 to the exponent, 3, divide by that new exponent, 3, put the plus c for a generic constant. Replace your u with what it was, and dude, I don't want to take that to the third power. I'd leave it like that. All right.